Today we will find the acceleration of the particle in force oscillator or acceleration of force oscillator. We know that acceleration is the rate of change of velocity, and velocity is f naught upon zm into e raised to power iota omega t minus phi. So when we put the value of velocity here, then we will get A is equal to ddt of velocity. Velocity means f naught upon zm e power iota omega t minus phi. So when we take the derivative of this term, then f naught upon zm will come out because it is constant, it is independent of time, so it is constant. And the derivative of e power iota omega t minus phi is e raised to power iota omega t minus phi. You know that the derivative of e power x is e power x. And the derivative of this iota omega t minus phi is iota omega. So this is the final value of acceleration. So we will get iota omega f naught over zm into e power iota omega t minus phi. So this is an expression for acceleration. Now we will consider or separate the real and imaginary part, because iota is involved on the right hand side. So this is complex term. So we will separate this complex term or separate this complex number into two parts, that is real part and imaginary part. So A become iota omega f naught upon zm e power iota omega t is cos omega t minus phi plus iota sin omega t minus phi, because you know that e power iota theta is cis theta, cos theta plus iota sin theta, where theta is omega t minus phi in this article. Now multiply these terms with this iota omega, so we will get iota omega f naught over zm into cos of omega t minus phi, and iota into iota square, that is minus 1 omega f naught over zm into sin omega t minus phi. Okay. So this is the expanded form of acceleration. Now you will see that on the right hand side, in this term iota is involved, iota is there. So this term is imaginary term, and in this term there is no iota, so it is a real term. You can say that it is real component of acceleration, it is imaginary component of acceleration. You know that we will consider only real component. You may take any component, either real or imaginary, you will get the same answer, but we will take real component of acceleration, real part of acceleration, that this, it is minus f naught over zm into sin omega t minus phi. So this is a real component. So we will deal with only the real component of acceleration. Now if we consider or find the phase difference between a real component of acceleration and a real component of force. So what is real component of force? You know that a real component of force is equal to f naught cos omega t. You know that f is equal to f naught e power iota omega t, and on solving or splitting e power iota omega t as cos omega t plus iota sin omega t. So this is real part of force is this. So this real part of force is a real part of acceleration. When we compare these two real parts of acceleration and force, you will find here it is cos, it is sin, even minus sign is also there, sin into minus sign. That is, when we compare both these, then you will get the phase difference, the phase difference between acceleration and force, acceleration and force. When we compare the phases, phase means angles. So here it is minus sine omega t minus phi, it is only cos omega t. So when we compare both, you will get, you find the answer, phase difference is phi is equal to, phase difference is phi plus pi by 2. You can find out. You may write this omega t or this omega t minus phi and plus minus 90, and you will get the same answer. So the phase difference between this A and F is phi plus pi by 2, the phase difference. Now we will study the variation of acceleration amplitude with driving force frequency. This is an article, as we have discussed in previous two articles, displacement and velocity article. So in this case, in simple words, it is A naught versus omega variation. A naught means the amplitude of acceleration. So what is acceleration amplitude? This one. Because when we consider this constant, that the maximum value of this acceleration is called A naught, and this is harmonic function. So A naught is omega f naught upon Zm. This is A naught. A naught means acceleration amplitude or maximum value of acceleration, and we will study its variation with omega. A naught versus omega. So we will plot the graph between A naught and omega. So on the same lines as we have studied in the previous articles, that is first case omega tends to 0, in the second case omega tends to infinity, and in the third case omega is at resonance. So first case, when omega tends to 0, so we know that we will put the value of omega as 0 in this equation, this one equation. So omega is directly involved in this value, but indirectly this omega is also involved in Zm relation. So you know that what is Zm? Zm is r square plus omega m minus s by omega whole square root. So this is Zm. So omega is also there in the value of Zm. So when omega tends to 0, then what will be the value of Zm? Zm is, it is r square. Omega into m, that is 0 into m, it will become 0. And it will become s upon 0 means infinity. So among all three terms, the last term s by omega will dominate. So this term will dominate. S by omega dominates among all terms. Therefore, we will omit these two terms and consider only third one. So s by omega square under root, that is omega approximately become s by omega, okay, because of its dominance. So this A naught become omega into f naught upon Zm means s by omega. So it will become omega square f naught upon s. At last, finally, we will put the value of omega as 0 here. So omega 0, 0 into something, it will become 0. So this is first coordinates, that is omega tends to 0, acceleration also become 0. This is first point which we will show in the graph. Now in the second case, first graph is there. The first point is this, coordinates for the first point. And second point, when omega tends to infinity. Infinity. You know that when you put the value of omega as infinity in the equation of Zm, then it is r square, that is finite value, infinity to m, infinity, and s upon infinity, 0. So this term becomes 0, this is finite term, and this term becomes infinite. So it means among three terms, this second term will dominate. Omega m will dominate when omega tend to infinity. So we may write this Zm approximately as omega into m. So put here a naught, because we have to calculate the value of a naught finally. So a naught become omega f naught upon Zm means omega m. So omega cancel with omega, and it is f naught by m. So when we put the value of omega as infinity, so there is no any omega. Therefore, when omega tends to infinity, then a naught become finite value f naught by m. This is second point coordinates, the coordinates of second point. Okay. And third case. In the third case means when omega is at resonance. So in this case, we have no any particular value of omega at which the circuit become as resonance. So we have to find the value of omega at resonance. So what is that value? So firstly, we have to calculate the frequency at resonance. Then we will put that frequency in this equation, and finally we will get the value of a naught. So what is resonance? So we will apply the same formula as we have used in the formula of or expression of displacement x. So in this way, when omega is at resonance, it means the circuit is at resonance. That is, the value a naught is maximum. You know that the condition for resonance is that condition. It is that frequency at which the value of amplitude or acceleration amplitude become maximum, because maximum is the Renner value of resonance. So this a naught become maximum, or a naught means f naught over omega upon Zm, or Zm omega minus 1. Okay? You may write like this, because we will consider omega in the denominator part. If it is maximum, then this denominator should be minimum. This means Zm into omega minus 1 is minimum, because something upon minimum is maximum. So when a naught is maximum, it means its denominator should be minimum. So it is minimum. So we apply the formula for minima or maximum condition, that is the derivative of this Zm into omega inverse omega minus 1 is 0, because this term is minimum and the derivative of minimum is 0, because maxima and minima is taken as constant in derivative form, and so I have taken the derivative on both sides. Taking derivative on the left side, it will become ddt of Zm into omega inverse is equal to derivative of minimum means 0. So this is the main condition from where we can calculate value of omega or frequency. So you may put the value of Zm here. So ddt of this Zm is r square plus omega m minus s by omega whole square root into omega inverse, it is 0. So you may calculate its derivative. So there are two terms, first term and second term. So you may apply the formula of product rule, that is first term as it is into derivative of second term plus second term as it is in derivative of first term, and then solve it, and you can find is equal to 0, and you can find the value of omega as value of omega for this article become under root 2s square, under root 2s square over 2ms minus r square, 2ms minus r square. So, you may find this value by solving this condition. So, you may take derivative of this term and equal to put that term is equal to 0, and finally taking common or on simplification you can finally got this answer, omega is equal to this. So, this is the frequency. So, I have put this frequency as omega double dash because we have used omega naught, omega dash in the previous articles. So, this is a new frequency. So, I have put this frequency as omega double dash. So, this is a resonance frequency. So, it is that frequency at which acceleration become maximum because we have proved this frequency from the condition of maxima. This is resonance frequency. Now, we will plot the graph between acceleration amplitude versus omega. This one. So, omega has three values. This is omega equal to 0, omega at omega double dash, that is at resonance, and the third value is infinity. Omega is equal to infinity. This is infinity, omega double dash, and 0. So, we have 3 points, 3 coordinates. What is first coordinate? First coordinate is omega tend to 0, acceleration is also 0. So, that is omega 0, acceleration 0, this one. In the second case, omega tend to infinity, acceleration is f naught by m. F naught by m is finite value. Let its value is f naught by m, and omega is infinity. This acceleration is f naught by m. This one. Okay. This point is omega is infinity, and acceleration is f naught by m. And third, when omega is omega double dash, this frequency at resonance omega double dash, then a naught is maximum. So, I have not solved the maximum value, but its value is maximum. Let this value is, it is maximum value. So, omega double dash graph will, this point will show at that position. So, we can plot the graph, this type of graph. So, this type of graph is obtained in case of acceleration versus omega. So, overall, if we compare three graphs, that is amplitude versus omega, velocity naught versus omega, and this one acceleration versus omega graph. So, we have observed that in the first case, this graph is like this. Okay, it starts from the first graph of displacement start from finite value and at 0, reaches at maximum and ends at 0. In case of velocity, this graph starts from 0 and reaches maximum value, and then again finally reaches at 0. It starts and ends both at 0. But in case of displacement, it starts from finite value f naught by s, and ends at 0. And the third case, in case of acceleration, this graph is like this. Okay. This graph starts from 0 value, this one, and ends at this finite value f naught by m. So, three types of graph we have observed in our previous or this article. So, this is a variation of acceleration versus omega. Thank you very much.